want to go with a colleague somewhere with port first. So some of you, what you always do is to disconnect a cable from one of the computer, or you pick a cable, connect it in your computer, and then within seconds, like, this cable doesn't work. Okay? Even in packet tracer, it is clear. The moment you connect it, you will see one side on the side of the computer. It goes to green. Okay? But at the switch, it starts from amber, takes time, and then changes to green. Okay? So it is going through those 5 states. See? So the reason why we need the port first is that there are those devices, in case let's say power goes off, come back, it should just take seconds for that port to go to forwarding state. But this is what you need to note. The links between the switches should never put them in port first. Should never give them, assign them to port first. Because for it, so I'm going to show you the port first and then BPDU, some example there. Okay, so this is my packet tracer. Then I'll pick a switch, maybe another one. You can even have a third one, string, and then PC. Maybe for PCs you can have 2, then cabling. Even if you use a straight through, no problem. So I'll use 1 to 1, then I'll use maybe 2, this 3. So you see what is happening? Amber and blah blah. So those 15 minutes from listening and then learning and blah blah, it's a must. That is the protocol, that is the procedure. They have to count them. They have to be counted. Now this is another switch. If I put a port, now this one here it has synchronized, but these ones here are still doing that. So I'll just start with which port. If I connect to this, let me look for a port. Which port should we use? Let me use port 10. So I'll call port 10, enable, go to global configuration, mode, call port 10, interface 10, 0, 0, 10. Then from 10, it's switch port. Switch port. Switch port was spanning tree. So we need a port, switch port. Yeah, and then we have like this. Maybe use this. Okay, so under this, once you call the interface, you just go straight to spanning tree. So after spanning tree, let's say, as you can see the options that we have there, we have BPDU, we have post, we have guard, we have link type, you have link type, we have the port first and blah blah. So for us, we are interested in BPDU guard, BPDU guard, and we have to enable it. As you can see here, you can disable and then enable. So if it is enabled, you can go there and disable it. Okay? But now I need disable, sorry, I need enable. Enable. See that spanning tree BPD tree, then BPDU guard enable. So this port, it should not receive or send or forward BPDU messages. See? So now that we have that statement with us, I'm going to pick a cable, connect it in any port here, then try to connect in port 10. So every time, by default, they should, once you connect to the same device, they have to synchronize, to negotiate which one to be the root bridge. So in our process of negotiating, the BPDUs are going to be sent and received. So we don't need to do anything. All I need is to do the connection. So instead of negotiating and then it becomes green, you see what we have there? So we can open and we see the statement that we have there because the notifications are there. Maybe this. The notification, they have to be there. So look at this. Error disabled. BPDU guard error. BPDU guard error detected on port 20. Putting this in error. You see this? It is in error disable state. It's not in shutdown, but it is somewhere in between. Okay? So this, even if I connect the right code, because if I connect any device, it should work, but it is in error. It has error. I need to first rectify the error. And how do you rectify the error? I'm still in the mode which is port 20, 10, sorry. I need to put the command shut down. You see that? And then no shutdown to activate it. But still it's going to, you see that? It goes back. Because the moment you activate it like this, it will start. Because the other switch, we never disabled. For the other one, it will initiate. It's going to prompt the message. Get it? I don't know whether you guys know. So when it comes to this other switch, I will just try out. Okay, which port is this? Click port 2. So I will deal with port 2. So I will access this switch called switch 2, enable, then configure terminal, then interface F0/2, and then you say switch, not switch port, but spanning tree. Tree, and then port first. Port first. Do we need enable? Disable trunk. So meaning that if it's disable, if it is enabled, you can disable it. So we have that you stop there. So the command is this. But there is this disclaimer that you're seeing here, though some of us, we don't like reading the notification generated as you're doing the configuration. So this port here, it's not supposed to be done on the trunking link. The trunk links, they are there to loop, to interlink, to bridge the devices. See? Switch 1 with switch 2. So if you do that, then your network is likely to support loops. See? Okay. Because here the functionality, it helps the port to go in forwarding state there and then immediately, as you're going to see. So we're done with this. Now it's time to check our network. So this is what I'm going to do. I will begin with this. See this? Disable it, disconnect, and then connect it again. On port 3, you see that? So this it has to go through the steps, the stated steps. And as you can see, I'm even relaxing. And then go and disconnect this in port 2 and connect it. Immediately it's going to be the first to synchronize before this one synchronizes. It is port 2. You see this? This one here, it hasn't even. I'm disconnecting and then again connect. Port 2. You see this? Now it has. Let me go back. Port 3. And then go back here. You see this? Port 2. You won't see it negotiating. Look at this. See that? But please do not do this between the switches. If you do that, it's going to create loops. Because for it, it doesn't wait. It's like BPDU guards. Sorry, not BPDU guards, but the BPDU messages, so that they are up to date. Okay? They are up to date. And then another thing is about STP and STP and RSTP. So I'll just pick my switch, where the switch here, pick this, have it here, and then now and then so we have this and then this. Then I will get this, and then this. Well, let me use this. I have is this, is this. Is this. This is this. This. So yeah, I'm not following any syntax. All I want is just to connect my devices. And so when you look at this by default, just not by default, physically, this is what you need to know. So physically, this is what you need to show in packet tracing. That when you look at this switch here, the ports of this switch, so the links, the cables, are you seeing the cables from this switch that they are lighting green on both ends? Are you seeing that? Here and then here. Because the root bridge, it is supposed to be able to reach all other switches. Okay? So just look at this and use this concept. That since this link here, it's green, this is the root bridge. But in Pavira and STP, please do not use this. Because all of them, you will see them green. Actually, when you see something like this, and all of them, they are lighting green, all of them, you know that you have Pavira and STP. Because there you distribute. You get it? You distribute. In class here, you are the both. Okay, here in class you're a student, but in another class, you're a trainer. Maybe somewhere you're all together. So on this one here, to know that you have Pavira and STP, that is when you see green shroud. But when you look at this and here, there is a port that is blocked. So when it comes to this, when you look at this, it's this switch that has both ends here green, both ends here green. So this is the root bridge. Okay. Okay, so here what I wanted to test, rapid and then spanning tree flat. Yeah? So I'll just come here on this, I will leave it and then run this command on this. Spanning tree protocol, enable, then configure terminal. Then it's spanning tree, then VLAN, because by default you have VLAN 1 there, VLAN 1. Biology on span, we need the mode somewhere. Okay, yeah, it is here. So it's spanning tree, then mode. Mode it's R, as you can see. It is rapid. So that rapid per VLAN STP. So I'm going to copy this to save time because some of you, I can see you're dozing. Okay, so I will do this and do all these other switches. Even this. Apple configure terminal, and then I'll paste it, press enter, go to this one here, do save, enable, then configure terminal. I'll paste. Okay, so here we are. But this it is still synchronizing. Stable at the end of it. See what to do. Okay, it has stabilized. So I want you to look at this. I'm going to disconnect the main, this one of these. If I disconnect this one here, it has to come up. If I disconnect this, it has to come up. Okay. I want you to see the time that it's going to take to synchronize. Okay, to converge. So I'm deleting this and then this. Let's connect again. Let's connect. Let's connect down again and we see. I hope you've seen the difference. This one here, it is still recalculating. Because now on the other one, the states are only 3. And then this one here, they are 4. Okay? That is our rapid, and then the rapid, and then the flat, the STP flat. So here you can actually go ahead and verify by using the command show VLAN. This is what I want you guys to go interact in your free time. Those who are going to stay behind and even those who are going to go home. All you need, just open the router. Example here, so not the router, but you have this let me use this, that we have these three switches. You can open a switch, go to command line prompt, enable, run the command in privilege mode, show STP, spanning tree. You press enter. So with this, look at this, that you are under VLAN, see this, under VLAN 1. The ports there, we have port 6 and 12. And these are designated. Okay? Then we have this section here, this section that you're seeing. I think that section, it indicates the information of the root bridge. Okay? The information of the root bridge. Now, when you look at this, there is a statement. This bridge is the root. And when you look at what we have here, the priority, it is the same as what we have here. See this? And then this. Even when you look at the MAC address, this, it's the same as, see? Indicating that it's the root bridge. This information that you're seeing here is for this bridge ID, for this switch. But all these other two switches, they have to have this information because this is the root bridge. Your class representative, you know him. The same one. Okay? So this section here, it clearly indicates the priority, the MAC address of the root bridge. Then on this where we have this bridge is the root, there will be a cost from this switch to the root bridge. What's the distance? Okay? Distance. And then this information, it's for this computer, sorry, for this switch. And then these are the port rows. So what I want you guys is, on each switch, go to this second section here. Pick the, because look at this, where is this coming from? When you look at this, the priority, the default, it is here, 68. I think it, 68. But with the system ID, extended system ID, which is the one, so on this ones you add the 1, then you get your 69. Eh? Okay, so I want you to go on every switch and then you record these two. Record what you have here, the priority, of course it will be the default, and then you record the MAC address. Okay, so don't waste time. What you can do is just highlight this. For this one here, you can duplicate because by default it will be that for all the switches. Now this one here, it can't be default. So you highlight and then right click, copy this, and then switch 7. Where is switch 7? Then come and press a notch. So our priority ID is 32 700, then 69. Not so. Then the MAC address. You see that? That's the MAC address. And then you go to the other one, which is this. Do the same. Enable show spanning tree. So when you look at this, it is still the same, but this time we have the, instead of this bridge is the root, now we have post. And even the port that is used to connect to that. So here, I will just copy this, it's what I want. Then when I come here, I will manipulate this. So it's 32769. Then lastly, enable show spanning. So still the same as you can see, but I'm interested in this. Then on this, okay, so it is give a 32, then 760. So here we are saying physically by looking, it's because the port here it's green, 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 green. See that? But for this scenario only, for this case, are you together? For this case. In scenario like where you have the fourth, see now you have the what? The rectangle. Huh? There will be actually this switch here and then this and then this. There will be like two switches with the links, green, green at the end, two of them. But now here, look at this. Let's prove that this is the root bridge by comparing our the MAC addresses. Okay. So you look at this. I will start here. This is a 0. You go to this is a 0, a 0. Okay. Go to the next one. This is a 0. It's a 0. It's a 0. We go to the next one. Here we have E. We have 6. Then we have a 0. You see that? So even if you stop there, we're done. Okay? We are done. Because now when we're comparing this hexadecimal value, that it's E, here it is 6, but on this it is a 0. So we've proved that this is our root bridge. And even in the statements, here, as you can see, it is there. This bridge is the root. So I want you to, because if you try it out, you will not get exactly what I have. Use the same syntax, same concept, and you see what you're going to get. The rest, you will see the recording.